Good morning to all. I am Dr.B.Angelin, Assistant Professor, Department of Information Technology, working in Dr. S.N.S. Rajalakshmi College of Arts and Science. Now I am going to discuss about process concepts in operating system. Process concept in operating system, process to process concept and states. Next one is PCB, process scheduling, operations on processes, inter-process communication, examples of IPC systems. Process concepts. An operating system executes a variety of programs, batch systems, jobs, time-shared system, textbook users. The terms job and process almost interchangeably. Process, a program in execution. Process execution must progress in sequential fashion. Next one is multiple parts. The program code, also called a text sections, currently actively including program counters, processor, register and stack containing temporary data. Process concept. Function parameters, return addresses, local variables, data section containing a global variables. It heap a containing a memory dynamically allocated during runtime, and program is passively entity stored on a disk process inactive. And next one is program becomes a process when executable file loaded into memory. Execution of program started via graphical user interface mouse clicks, command line entry of its name, etc. One program can be several processes. Consider multiple users executing the same program. Process state. Process state, as a process execute, it change states. New, the process is beginning a created. Running state, instructions are being executed. Waiting state, the process is waiting for some event to occur. Ready state, the process is waiting to be assigned to a processor. Terminated, the process has finished to execution. Hardware features. The hardware features by monitors from fetching, insist, size and relinquish. Memory protection. When user program in under execution, it must not attempt to access the other user's memory area. If so, the processor hardware detects is as error and transfers the control to the monitor. Monitor aborts the job with an error message and takes up a next job. Timer is to avoid a job monopolizing the processor. It sets time at the beginning of the job. If timer expires, user's job is stopped and control transferred to the monitor. Privileged functions. Privileged instructions are executed under monitor mode. If such instructions are happen to attempt by user, then control is transferred to monitor. All input-output instructions are privileged instructions, which prevents the user programs from reading the job control instructions. This facilitates the operating system in relinquish control and regaining control from user programs. Time sharing system. In 1960, programs need dedicated computers, which was not possible as it was too costly in those days. Application with more user interactions needs dedicated computers. Multi-programming designed to handle multiple interactive jobs referred as a time slicing, used to share processor among multiple users and makes each user to feel that they have dedicated system but interleaved among all of them. Hence, if an user using the system, then each user see one of the effective computer capacity. Time sharing. Compatible time sharing system. Of the first time sharing operating system developed in MIT by group known as Project Mac, ran on a computer with 32,036 words of a main memory. Growth. The growth is the use of time sharing system, and more recently computer networks has balked with it is a growth in concern for the protection of information. Much of the work is security and protection as it relates to operating system can be roughly grouped into 4 categories. They are availability, confidentiality, data integrity and authenticity. Key responsibilities. A key responsibility of the operating system is to manage the various resources available to it. Any resource allocation and scheduling policy must consider three factors. Thank you.